Okay, this is going to be the second projectile motion discussion we're going to have. The first one was actually the ball thrown straight up in the air, which is technically a projectile. In order to be a projectile, you've got to have a combination of two motions occurring simultaneously. In that case, we had an up-down thing going on dealing with gravity, that's the vertical. There was a zero horizontal, so technically, since we can identify the horizontal as zero, that is all part of the definition of projectile. This time we're going to have what we call a zero degree projectile motion, which means that we're going to shoot a cannonball in this scenario here from a cliff. We'd have a cliff, platform, whatever, that's not on the ground, it's above the ground, and it's going to shoot straight across. That cliff is 35 meters high, and we want to know how long the ball's going to stay in the air and how far will it go. Okay? So, this is projectile motion, like I said, is a result of a forward motion, which is the horizontal, and a vertical motion, which is the gravitational pull on the cannonball pulling it down. And since we need to do both, we have, or realize that both are occurring simultaneously, we're going to have to use the one that's going to determine how long the ball stays in the air, and that's going to be the gravitational pull. No matter what happens in theory, because there may be a little air friction or air resistance, but we're going to pretend like that doesn't really exist at this point here. So we're going to deal with the distance formula of 1/2 at squared for determining the time it takes. We know the distance is 35 meters, that's how high the cliff is. The acceleration, of course, is g, and that's 9.80 meters per second squared. So we're going to solve for t squared to figure out the amount of time it's going to take for it to stay in the air. So let's do that real quick. So we're going to make ourselves a pretend cliff. Now we all know cliffs are all perpendicular to the surface of the rock there. No, they're not. But we do know here that the height of this thing is the distance that the object is going to travel down, which we said is 35.7 meters. We also know that as soon as the ball leaves the cannon, it's going to start dropping. Gravity works on it the instant it comes out of that cannon. So we'll have this cannon here, and the cannon's going to shoot straight ahead initially, but as soon as it leaves the cannon, it's going to create a parabola. And that parabola is going to land, is going to describe the landing of the ball at a particular point, and we will identify as d for distance for that. This is height, which is a distance, but this is the horizontal distance that we're trying to solve for, and the amount of time it's going to take for it to drop. And like I said, because the initial velocity downward, the initial vertical velocity downward is 0, then we can use the formula, like I said, d equals 1/2 at squared, where a is g because it's the vertical, the gravitational pull on it. So this is going to be equal to 1/2 times 9.80 meters per second squared equals the distance, times time squared, sorry. And that's going to equal the distance is d, which is 35.0 meters. So we go through the mathematics for this. This is 4.90 meters per second squared times t squared equals 35.0 meters. We're going to get t squared by itself, so we're going to divide both sides by 4.90 meters per second squared. That cancels out there. And then this is going to give me a value for t squared. And I've done that on the script, so if I take a look at the script, I see that value is 7.14 seconds squared. meters cancel out, we got seconds squared in the denominator of the denominator, which puts it into the numerator. Now we take the square root of both sides, and we find that the time it takes for it to hit the ground is the square root of 7.14. Again, I calculated that on our script, and we have 2.67 seconds. So that answers one of the two questions, and now we can use that to figure this out right here, because the horizontal velocity is non-accelerating. It is a constant, in theory, a constant value. Of what? Well, since it's non-accelerating, we use d equals vt. The d then equals the velocity, which we said was, I believe, 250 meters per second, right? Yeah, 250 meters per second times 2.67 seconds. And that turns out to be, again, this has been calculated, 668 meters. So just right around 7 football fields long, but it only takes less than 3 seconds to get there. So that's a pretty high-powered cannon, but typical. Okay, so this is all there is for 0 degree projectile motion using the formulas that we described here. So, your practice problems. We have 3 of them here. These are your problems. So go ahead and work on them. Again, let me know if you have any issues. So, good luck.